All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online GATE preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay, and this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video, and this video is taken from online video course of Endurance Engineering Academy. So let us start with the next case. Okay, so this is center of parallel forces. This particular topic is going to be very important when I start center of gravity, centroid and center of mass. This is something which is going to act as a base. Okay, so that is why I just want to discuss about center of parallel force first, then I will start center of gravity. Okay, so these two are the parallel forces which I taken, 200 Newton and 100 Newton. As we already discussed about coplanar parallel force system, I hope that these are something which is very easy for you to answer, right? So two forces, 200 Newton and 100 Newton are the forces which is acting on this body. So what will be the resultant? It's very obvious, to unequal force acting in the same direction. So the resultant is going to act in the same direction as that of these two, and the value will be just algebraic sum of these two. Okay, so that is going to be, resultant is going to be 300 Newton, and let us consider it is acting at a point C. Now how to find out the position, that is how to find out the line of action of this resultant? Simple, as we already know from Varignon's theorem, we derived it also, right? What is the thing? And also we identified that for a two equal forces, for two forces which is in parallel, which is acting in the same direction, resultant will be lying in this region. Okay, will be lying in this region, that is in between A and B. Okay, if it is of opposite, if it is of one is acting up and another one is acting down, then resultant will be in the region like exterior to larger force. Suppose if 200 Newton is the larger force, then resultant will be in this direction, as we already discussed. If this force is acting down and this force is acting up, and if this is 200, that is if it is more, then resultant will be acting this side. Okay, so I hope it is clear now. Now what I can do, I need to find out the position. How can I do? Simple, I already used Varignon's theorem and we got the value also, right? What is the value? The force divides it in inverse ratio. Okay, so inverse ratio means P by Q will be equal to, if this is P, then P BC, right? P by BC. For P it has to be BC, and for Q it has to be AC, that is inversely, right? For P it is BC, this side distance. For Q it is this side distance. So BC by AC. Okay, for P it is BC, for Q it is AC. In an inverse ratio it is dividing. P is 200 Newton and Q is 100 Newton, and BC is not known, AC is not known, so let it be BC by AC. So 2 is to 1. So BC is to AC is equal to 2 is to 1. So ratio is 2 is to 1. The given AB distance is 3 meter. Okay, AB is what? AB is what? AC plus BC, right? So let us take some like this is from basic aptitude only, right? So total units was 3 units, right? Total units was 3 units. Let me just take it as 3, what I can take? I will take it as 3K. Total units was 3 units, which means BC plus AC, that is AB is 3 units, that is 3K. I already know AB is 3 meters. Okay, so which means K is equal to 1, which means 1 unit is corresponding to 1 meter. So what will be 2 unit? See, BC is what? BC is what? 2K. AC is what? 1K, right? So BC plus AC, that is 3K, that is nothing but AB. So 3K is equal to 3, so K is equal to 1. Okay, if K is 1, what will be BC? 2 into K, so that is 2 times of 1, which is 2 meters. And AC is 1K, which is 1 meters. So BC is 2 meters and AC is 1 meter, which means this is going to be 2 and this is going to be 1. This is what I am getting. This we already know, right? This we already know. The resultant force will be close to will be close to higher magnitude force. 200 is greater than that of 100, so resultant will be close to it. Okay, this is something which is basic, which we are getting it from our basic idea. Now going to second case. What I'm doing, listen carefully. I'm just changing the orientation. I'm just changing the orientation of these two forces. I'm not changing anything else. Let us consider I'm changing it to some 30 degree. Okay, I'm just twisting it. Okay, I'm just changing the orientation, but the positions are not changed. Still A and B are A and B only. So distance between these two is 3 meters only. Okay, distance between these two is 3 meters. I'm just rotating it. I'm just changing the orientation. Okay, so this is also 30. Okay, this is also 30. Okay, or you can just keep it as some theta. Okay, some theta. Yes, some theta. Now how to find out resultant? Finding out resultant is very simple, because this force and this force are parallel, right? So obviously if I add them both, I'm going to get the resultant, and they are acting in the same direction also. So I will just add them. So I need to draw it parallel. Yes. So this will be my resultant. That is also going to be 300 Newton only. So resultant has not changed. What I'm doing here, instead of P acting vertically, instead of Q acting vertically, I'm just rotating it. Okay, and it is acting at an angle theta. Now my aim is to find out what is this. Where does C occurs now? How to determine it? Simple. Just listen to me carefully. If you observe this thing properly, this P by Q is equal to BC by AC. P by Q is nothing but ratio of these two forces is equal to BC by AC, where BC is perpendicular distance. You observed properly, perpendicular distance between resultant and force Q. Okay, and AC is perpendicular distance between resultant and force P. So it's a perpendicular distance. So when I'm applying here also, I need to take perpendicular distance. I will use another color. Yeah, perpendicular distance, and let it be A, let it be C dash, let it be C double dash. Okay, so now P, that is 200, by Q, that is 100, or else simply P by Q, which is equal to what? Which is equal to, sorry, this is C, this is B, I'm very sorry, this is B dash. Okay, which will be equal to P by Q in inverse ratio, right? So B dash C dash by A C dash. Okay, now listen carefully, just small geometry only. If I draw a line like this, okay, again perpendicular to it, let me mark this as B double dash. Can I say C B double dash and C dash B dash as same? C B double dash is equal to C dash B dash. Obviously those two are parallel, so they will be same. Okay, now listen, take this triangle. Okay, this triangle, if this is theta, okay, if this is theta, what will be this angle? What will be this angle? It will be theta, right? Okay, now similarly, if yeah, let it be, listen, if this is theta, this will be theta, right? You just take this triangle. Which triangle? B double dash and C. It's a right angle triangle. It's a right angle triangle, right? Now what about this? What about this triangle? ACC dash. Okay, ACC dash. This is right angle, obviously. If this is theta, listen, if this is theta, what will be this angle? What will be this angle? What will be this angle? That angle will also be, it's opposite, right? It's opposite. So this angle will also be theta. Am I right? Very simple actually. Let me draw it and show you. Yeah. Yes. If this is theta, these two lines are parallel. Okay, these two lines are parallel. So if this is theta, this will also be theta. Okay, obviously that is very general from geometry. Okay, so this black color line is this one, and this red color line was this one. So if this is theta, then this will also be theta. Now compare the triangle. Compare B dash C and ACC dash. Compare it. Those two are what? Those two are symmetric triangle, right? Both are right angle triangle, and this angle is same, this angle is same, this is 90 degree, this is 90 degree, and even this angle will also be same, because this is theta, this is 90 degree, so this angle will be 90 minus theta. This is theta, this is 90 degree, so this angle will be 90 minus theta. So these two triangles are symmetric triangles. So what I can do? Simple, I can use this logic. AC by CB, okay, or AC by BC will be equal to what? That is ratio of this side by this side. I can equate it with AC by CB double dash, right? AC dash by CB double dash. See, this distance AC by BC, okay, that will be equal to AC dash CB double dash. Am I right? Just I'm using the symmetric triangle property. That's it. Now, what is CB double dash? We already know. CB double dash is nothing but C dash B dash. So that is going to be equal to A C dash by C dash B dash. Now compare it. AC by BC is equal to what? A C dash by C dash B double dash, right? So I will just reverse it. If I inverse it, what will happen? C dash B dash by A C dash, which is equal to, this side will also get inversed, BC by AC. Yeah, now check it. Now compare this to. B dash C dash by A C dash. A C dash is equal to what? BC by AC, which is equal to BC by AC. So what I can conclude? I'm getting the same equation, right? I'm getting the same equation as that of our first case. Even after twisting it, even after rotating it by an angle theta, I'm getting same equation, which means still the distance between A and C will be, what is the distance I got? 1 meter, and C and B will be 2 meter. So still the resultant is passing through same point. Now going to that case. Now this case, what I did here, just rotated it, that is P and Q, okay, these two forces, I'm rotating it, and I'm bringing it completely down. Okay, so what happens? 200 Newton now acting down, 100 Newton is also acting down. Again, a resultant is going to be just algebraic sum, 200 plus 100, which is 300, which is also going to act down, so that is 300 Newton. But what will be the position? Nothing, it's very simple, right? P by Q, this is not going to vary. P by Q will be equal to what? Inverse ratio is BC by AC. Am I right? For 200 Newton, I need to take this distance. For 100 Newton, I need to take this distance. Is the equation varying? Here also P by Q is equal to BC by AC. There also P by Q is equal to BC by AC, which implies still I will be getting this as 1 meter and this as 2 meter. So I will erase it and I will do one more case. After that, I will give you the conclusion, very important conclusion. So just revisit all these 3 cases. We will do 4th case, then I will give the final conclusion. So now I oriented this in this direction. Okay, initially both P and Q was acting upward, then it is tilted a little, and then we kept it completely downwards. The two forces are acting downwards. Now it is tilted in this direction. Let us take this angle to be theta. Okay, this angle to be theta. These two are parallel. If these two are parallel, obviously the resultant is going to be what? The resultant is going to be like this, just summation of these two. Okay, it is just summation of these two, and the resultant has to be parallel also. The resultant has to be parallel to this. Okay, so 200 plus 100, which is 300. Okay, so this point is C. Now I need to find out this AC and BC. Okay, so how can I do that? Again, simply we know that for a parallel lines only, right? So if I draw a line like this is perpendicular to force P, and again this is perpendicular to force Q also. So obviously I will take this as B, this as C dash, this as C dash, and this as A dash. Okay, if I do that, what I can say? I can write 200 by 100, which is nothing but P by Q. Let me just write it as P by Q, which is 200 by 100, which is equal to what? Which is going to be equal to P by Q. So for P I need to use this, that is inverse ratio, right? So B C dash by, for Q I need to use this, which means A dash C dash. Now I need to replace this B C dash and A dash C dash with AC and BC. How can I do that? Very simple again. What I can do, this is AC, right? So what I can do, just a minute, I will draw a line like this, that is a perpendicular. This is actually a bit small, but anyways, yeah, like this. Okay, it is perpendicular to this. Okay, this is perpendicular to this. If this angle is theta, this is 90 degree. I hope you could see this. This is 90 degree, this is theta. Already from this triangle, okay, from this triangle, this is theta, this is 90 degree, then what will be this angle? What will be, sorry, not that angle, 180 minus 90 minus theta, so this angle will be 90 minus theta, am I right? This angle will be 90 minus theta, so this angle will be theta. Okay, so finally what I will get something like this. This is A dash C, 90 degree, this is theta. Okay, similarly if you take BC dash C, okay, BC dash, sorry, this, let it be, yeah, this is A double dash, I'm sorry, A double dash, okay, A double dash C, this angle, this triangle A double dash C, and similarly this triangle, okay, yes, this is 90 degree, this is B, and this is C, this is C dash, this will be theta. Okay, so these two are symmetric triangle, again 90 degree, theta, theta, this will be 90 minus theta, this will be 90 minus theta. Okay, so then what I can conclude? Simple. This distance by this distance, okay, this distance by this distance, A double dash C by BC dash will be equal to AC by BC. Okay, AC by BC. Now, A double dash C, this is A double dash C. Okay, this is A dash C dash. So those two are parallel. So A dash C dash will be equal to A double dash C. So instead of this A double dash C, I can write A dash C dash by B C dash, which is equal to AC by BC. Now, AC by BC is A dash C dash by BC dash. So if I reverse it, then BC dash by A dash C dash will be BC by AC. So in place of this, I can write it as BC by AC. What is the conclusion? You itself can answer after giving all the 4 cases. You itself can answer what is the conclusion. Very simple conclusion. You orient it anyway. Okay, two forces are there, two parallel forces are there. You keep it like this, or you tilt it like this, or you completely tilt it like this, or you tilt it like this. Whatever direction you want, you tilt it. Okay, two forces. Okay, P, Q. Yes. If it is this, then my resultant will be somewhat like this. Now I'm tilting Q, I'm tilting P. Okay, in whatever direction you want, you do it. Okay, in whatever direction you want, you do it. Okay, I'm tilting it like this by an angle theta 1. Okay, by an angle theta 1. Then resultant will also get tilted by an angle theta 1. Resultant will also get tilted by an angle theta 1. But the point, okay, the point through which the resultant is passing is not going to vary. Okay, until or unless you are not changing the point of P and Q. Okay, here what I'm doing, I'm just changing the orientation. I'm not changing the point. For example, instead of tilting it like this, if I tilt it like this, if I tilt a force P like this, okay, at an angle theta 2, and similarly Q, okay, at an angle same theta 2, okay, but it is passing through the same point. It's passing through the same point, and I'm not changing the magnitude also. Magnitude still remains Q. Then my resultant will also get tilted, okay, by a same amount theta 2, and it will pass through the same point. Okay, so that point through which resultant of the parallel force, here I'm just taking 2 parallel forces, but you can take n number of parallel forces. So it is that point through which the resultant always passes through. Okay, that point through which the resultant always passes through, irrespective of the orientation of the forces. Okay, whatever may be the orientation, let the two force be vertical, or it is inclined in this direction or inclined in this direction, until or unless you are not changing this point. Okay, until or unless you are not changing the point through which the two forces are passing, you are only changing the orientation, then my resultant will also won't change its point through which it is passing. okay, only its orientation will change. So that point C, okay, I'm just marking it as C, that point C through which the resultant always passes through irrespective of orientation of the forces, okay, orientation of the applied force. Whatever orientation you keep, the resultant will always pass through that point, and that point is called as center of parallel forces. Simply, it is the point through which resultant always passes. It is a point through which resultant always passes irrespective of orientation of its forces. Okay. So let us proceed with one equation for this center of parallel forces. Suppose if n number of forces are acting, as I taken here, F1, F2, F3, F4, and n number of forces are there which is parallel. Okay, so initially let us assume all these forces are acting vertically. Okay, all the forces are acting vertically. By assuming this, we will get one equation. Similarly, by assuming if the forces acts horizontally, I'm not going to derive it, I will just give you the final equation. Okay, if the force acts horizontally, how to get it also we will see. Okay, so first of all, how to find out the resultant? Let us assume this is x-axis, y-axis, and this is our reference. Okay, our reference is origin. Okay, I'm assuming our reference is origin. How will be my resultant? Obviously, all the forces are vertical and they are parallel. So resultant is going to be in this manner, somewhere, I don't know where it is. But what I will do, I will just take this is my resultant, and let us assume that the resultant was acting at a distance x bar from our origin. Okay, from y-axis, that is from origin O, it is acting at a distance x bar. Now, the factor here is, I can easily find out R. Okay, so resultant will be simply the algebraic sum or vector sum. Since it is vertical, it is just a sum. Okay, so I need to sum it. If it is acting upward, you add it. If it is acting downward, you subtract it. But how to find out the position? That is how to find out this x bar. That can be determined by using Varignon's theorem, or well-known Varignon's theorem. What is it says? Moment of resultant about any point should be equal to summation of all the individual forces. Okay, summation of moments of all the individual forces about the same point. So if I'm going to find out moment of resultant about this point, all the forces moment should also be determined at the same point. Okay, so that's what I did here. First of all, moment of resultant about O. I'm just going to use the right hand thumb rule. I'm not going to worry about the sign and all. Okay, so R, which is acting up, and this is 0 here, right? So how it is? It's going to be counterclockwise, so I'm taking it as positive plus. Finally, I will give you an idea how to, like, final formula, how to consider it as positive, negative. I will give the final idea later. Okay, and similarly, summation of forces. What about this? F1, which is placed at a distance x1, right? So F1 into x1, so it is again counterclockwise. Again F2 into x2, again counterclockwise. F3 into x3, again counterclockwise. F4 into x4, counterclockwise. Similarly until Fn, okay, so Fn into xn, again counterclockwise. So all I'm taking it as positive only. So summation of all the moments is equal to x bar, which is the distance the resultant is acting from the reference. Okay, so I will bring this resultant this side, and finally in place of resultant I can substitute summation of all these forces. Since they are parallel, summation of all this will give me the resultant, right? So I'm just writing it as a conclusion like this: summation of xi into fi, where I varies from I is equal to 1 to n. Similarly, the denominator I am having summation of forces, so summation of fi again where I varies from I is equal to 1 to n. This is one coordinate of center of parallel forces. This is one coordinate. What about other coordinate? If suppose, let us assume, if suppose there was another force, okay, instead of forces acting vertically, forces are acting like this. I'm not going to solve this, I'm not going to derive it. I can easily say, you can easily say in fact, okay, Fn. Okay, so instead of forces being vertical and parallel, it is horizontal and parallel. Now also F1 and F2 is parallel. F2 is parallel with F4, it is parallel with Fn. All the forces are parallel, but they are vertical. And now, this, let us assume, let me use this blue color. Let us assume this distance was how much? Xn. This distance was how much? X3. And this distance was how much? x4, and this distance was how much? x2, and similarly this is x1. Okay, so how it is going to be? f1 into, sorry, I'm very sorry, I did a mistake here. Since I'm taking the distance in x direction, I taken it as x. So since now I'm taking vertical distance, right? So this is going to be y1, this is going to be y3, this is going to be yn, this is going to be y4, and this is yn, this is going to be y2. Okay, so that is, this force F3 is present at a distance y3 from x, and similarly this force F1 is present at a distance y1, and F2 is present at a distance y2, and Fn is present at a distance yn, and this is present at a distance y4. All I am taking it from the reference. Okay, now what will happen? Similar to this, I will get an equation. I will get an equation something like y bar is equal to summation of I is equal to 1 to n yi fi by summation of fi. Again, I varies from 1 to n. This is y bar. Okay, so this is x bar, that is y bar, and x bar comma y bar will be our center of parallel forces. So we got an equation for a center of parallel forces, right? If the forces are acting maybe in a body, something like this. Okay, F1, F2, F3 until Fn. Okay, yes. Now the question is, the derivation which I did for all the forces acting upward. What if the force acts downward? Okay, if the force acts downward, then very simple, your x bar is going to be, like here I'm just going to say for x bar because I'm not going to do it for y bar. So x bar will be simply like x1, x2, all those things you know, I guess. What if the force is acting upward, you just take it as positive, and if it is acting downward, you just take it as negative. So F2 is acting downward, so here I will be having minus sign, plus x3 into F3 plus etc. plus xn into Fn. So if the force is acting downward, you need to take it as negative. And similarly in the denominator also, if the force acting downwards, it should be negative. Okay, similarly for y also. Okay, so if it is acting right side, you take it as positive. If the force are acting left side, you take it as negative. Okay, for y, if it is right side, you take it as positive. If it is left side, you take it as negative. Both in numerator and denominator. And one thing to note here is, this is discrete system of forces. Okay, the forces are acting in a discrete fashion, they are not continuous. What does it mean? You would have studied in strength of materials, uniformly varying load, uniformly distributed load. In addition to that, also different types of load, sine curve, cos curve. A load can act in a sinusoidal manner also. So if you take some object like this, and if the instead of load acting in discrete manner, a load can act like this, distributed. Okay, distributed. We will be talking about this distributed load more in strength of materials, but anyways, this is how. If it is not discrete, if it is continuous, okay, so here the load will be distributed. The load will be function of x. Okay, as x varies, the load will also vary. Similarly, if it is vertical, then it will be function of y, whatever. Okay, so what you need to do in this case, simple, take a small strip. Okay, take a small strip. Let us consider this strip was present at a distance. Let me just remove this. This strip was present at a distance x. Okay, and the small strip's thickness was dx. Now at this small strip, let us consider the distributed load was W. Distributed load means it is Newton per meter. Okay, for 1 meter, how much load is acting? Okay, so that W into dx will give me total force or total load which is acting due to this small strip. Okay, so that will be equal to W into dx. This is Newton per meter, and if you multiply with meter, I will be getting the total force which is acting over this, okay, over this small strip only, not over the complete. I need to find out the complete, right? But here I don't need I don't need force, I need moment, right? Summation of moments by summation of forces. I hope you remember. So summation of moments means what I should do? Force which is acting on this strip is F, which is W into dx, multiplied by this distance. Okay, so x into F will give me the small moment dm. Okay, about any point, maybe if this is O, then this is O. Okay, so about that reference point O, x into f will give me, what is that? Sorry, this is not f, this is df. I'm very sorry. This is df. Small force, right? Small force, right? Due in this small strip, okay, in this small strip, the small force which is acting is df. Okay, that small force into this x will give me the small moment dm. Now, if I integrate this, I will get the total moment. So, integrating this dm, that is x into df, will give me total moment. Similarly, denominator what it has? Numerator it has summation of moments, denominator it has summation of forces. Summation is nothing but integration in continuous system. So, in denominator, it's going to be integration of df. This will be my x bar. Okay, right? I hope it is clear now, right? Now, what about y bar? Similarly, I will write it here. Y bar will be integration of y into df divided by integration of df. So, x bar comma y bar will be integration of x into df by integration of df. Similarly, their integration of y into df by integration of df. So, overall, if I consider discrete system, okay, if I consider discrete system, center of parallel forces will be summation of xi into fi by summation of fi, where I varies from 1 to n, comma, x is this, y is summation of yi into fi by summation of fi. Okay, and what about for continuous system? For continuous system, that is x bar comma y bar will be integration of x into df. Okay, how to find this df? You will be studying in detail when we are going for what is that? Strength of materials. Even in this mechanics also, we will be doing some problems. Don't worry. Okay, so x df by an integration of df, comma, integration of y df by integration of df. Okay, so this is x bar, this is y bar in continuous system. That's it. Now we got all the ideas, or we got all the concepts which is required for center of gravity, center of mass and centroid. We will discuss that.